Okay, now we're going to look at number 17 on the review sheet. So number 17 says a 925 kilogram car is moving north at 20 meters per second. So this is MAVA, 20.1 meters per second. It's moving north. So north is the direction. It collides with an 1865 kilogram car moving west at 13.4 meters per second. The two cars are stuck together. In what direction and speed will they move after the collision? So I want to find V prime. Well, the first thing I need to do is I have to draw my picture. So this is where I start. So first I'm going to draw the momentum of car A. So this arrow represents the momentum of A before collision. Then car B goes like this. So you notice I'm adding them head to tail. So this is PB. And then they stick together and they move off at one velocity. So this is going to be, remember the two vectors added head to tail is going to be P prime. Now remember, because they stick together, they have a combined mass. Okay? So the total momentum before, okay, remember we did MAVA plus MBVB is equal to MA plus MB times V prime. So that's what we're doing. But we're not doing it algebraically because they're not in a line. So now we have to do it vectorially. So this vector, PA, plus this vector, PB, added head to tail because they go at different directions, has to be equal to P prime. Right? So now I can calculate, so these form a right triangle. So this is actually easier than the other ones, because if this one's north and this one's west, from where I start to where I end up, there's my resultant. So this one's actually easier. All I have to do is find this, and then I use Pythagorean theorem to find that. Okay? So PA is MAVA, which is 925 times 20.1. So PA is equal to 1.86 times 10 to the 4. PB is equal to MBVB, which is 1865 times negative, because again, I'm using my same standard Cartesian sign convention up and to the right as positive, negative 3.4 meters per second. So PB comes out to be negative 2.5 times 10 to the 4. So now here's my picture. I just found PA and I found PB, and now I want to find P prime. So I'm going to use the Pythagorean theorem. So P prime is equal to the square root of PA squared plus PB squared. See, this is the opposite of what we did in the other problem. The other problem, they gave you the hypotenuse and you had to find the other two sides. Now we have the two sides and we're finding the hypotenuse. So this is actually easier. So this is equal to the square root of 1.86 times 10 to the 4 plus negative 2.5 times 10 to the 4 squared. So P prime comes out to be 11.2 meters per second, but my answer is not complete. Why is my answer not complete? Because vectors have both magnitude and direction, and I have to find the direction. So going back to vectors that we've been talking about all year, I measure the direction from the tail of the resultant. So here's my resultant, P prime. So I can measure this angle here. So this is a right triangle. I have opposite and I have adjacent. Opposite over adjacent is tangent. So tan of theta is equal to opposite over adjacent. So tan of theta is equal to PB over PA, which is negative 2.5 times 10 to the 4 divided by 1.86 times 10 to the 4. So when I do this, theta comes out to be 53.4 degrees, and then it's going to be east of north. Or I could write 36.6 degrees north of west, because those mean the same thing. That's this angle in here. So my final answer would be P prime is 11.2 meters per second at 53.4 degrees east of north. And that would be my final answer to find that. And that's it.